One thing that this question is testing is, can we draw a good diagram? So first of all, get a square just as accurate as you can. And then we've got an equilateral triangle inside the square because there's a point X such that XAB, okay, let me label ABCD. XAB is equilateral, so I could put a point down here and then join it up. And then YAD, put a point about here, is also equilateral. And then we're asked to show that XY is equal to AC. So AC is this diagonal of the square, and XY is here. Okay, now we can also do some other things. All these sides must be, because they're both regular polygons and they share a side, all these sides are the same length. I say all of them, not the green, not the green lines, all except the green lines, okay, because the green line is the diagonal. And that is actually really like quite a crucial thing in this question. Because we can kind of see that AC, right? We've got a triangle here involving AC, where AC is the diagonal. And this triangle, it's got a 90-degree angle, and then 45 here, and 45 here. Okay, that is like the main triangle kind of using AC. We can't really link it to any other ones. YX is then linked to one triangle itself, which I'm going to now highlight. What color shall I use? I've used quite a lot of different colors already. All right, I'm going with this turquoise color. So this here, I want to find out more about this triangle. Well, okay, we have that this angle is 60. And then because that angle is 45 and this one here must be 15. By the way, you should be like justifying this as you go. I'm just giving a verbal summary of what I would write down. Because that is 15, then because the whole thing is 90, then this angle here must be 30. Aha, I have a right angle. And because I have a right angle and it's isosceles, then this angle must be 45 and this angle must be 45. And actually we have congruent triangles because these two are the same. And we can say by side angle side triangle AXY is congruent to triangle ABC, and therefore XY equals AC. And that's enough. Actually, when I did it, I didn't actually use congruency as such. I decided to label all of these sides that I've said are equal. I called them all X. So then I've got triangle here. Okay, I've rotated it round, but I've got AXY. And it's, by the way, this is not to scale actually. I want to make it, just set that it's 45 degrees. So because this is X and this is X, then I can do X squared plus X squared square rooted. which is the square root of 2x squared, which is root 2x. So using Pythag here, and I can do the same for this one. I mean, to be fair, congruency is better, but if you don't know your congruency rules, then I feel like this way is also good. So I've got A, B, C. And this is also root 2x. So by Pythagoras' theorem, xy equals AC. I mean, I've actually technically used RHS congruency rule. So pretty much use any of them at this point. You know, they necessarily must be congruent. The only thing we've not like that we don't know here is that they are the same. But because all the angles are the same, those two sides are the same. You can't use SSS actually, can you? But yeah, SAS or RHS. Think of the ones that jump out. So just show the congruent or use Pythagoras' theorem to show the same, and then we can make this conclusion.